Good afternoon, Houston. Happy Tuesday. Meteorologist Erika Lopez here in the KHOU Weather Center, here for another weather school where we are talking about meteorological type of topics. And whether you're interested in meteorology, possibly future meteorologists tuning in, or whether you're just interested in learning a fun factor here or there, or if you're just taking a break from work. Either way, we're happy you're tuning in. Hope you guys are enjoying the beautiful weather that we've had across the Houston area. Loving the sky cams the last couple of days. Day 2 is spectacular weather where temperatures are comfortable, humidity is low, and that's going to be our topic today. Humidity, the dew point, relative humidity. What's the difference, right? Why do we as meteorologists love to talk about the dew point and the humidity and the relative humidity percentage, but what does it mean, right? Especially when we see relative humidity percentages very often here in the Houston area in the 90s, close to 100%, but we focus in on the dew point. So there's a difference, and I'm going to talk about that throughout the next few minutes. So happy you guys are tuning in. Okay. North wind in place right now. That north wind is bringing in a drier air mass. So that's why this dew point, which is how much moisture is in the atmosphere, is lower today. So how humid is it? All right, this is going to help answer the question if you are, having a conversation with your friend. It's something that you can use to impress them with the fact that if they ask, how humid is it outside? And you let them know, well, it's dew points are in the 60s or dew points are in the 50s. Right now, dew points are in the 40s. You can let them know relative humidity is not a good measure of how humidity feels. So what does that mean? When we take a look at this number, relative humidity, this is not the best number to calculate how much moisture is in the atmosphere and to explain to your friend how muggy it actually is. The best way to describe how muggy it actually is looking at the dew point. The dew point is how much more accurate, it's a much more accurate way in terms of how it will feel outside. Here's the reason why. The dew point shows how much moisture actually is in the atmosphere. The relative humidity percentage is just a calculation of how much moisture it is in comparison with the temperature. So the key word to relative humidity is relative. That number, that percentage, it's all relative to what the actual temperature is. The higher this temperature is, the higher our dew point can be. That means the more moisture we can hold in the atmosphere, which leads into us as meteorologists in the dead dog days of summer. We talk about what it feels like outside because it is so hot, the temperature is so much higher that it can actually hold so much moisture. And that's when it starts to feel oppressive and could get dangerously hot for a lot of us. Okay, so I know that's a lot of information, especially if this is the first time that you're learning about the difference of relative humidity and dew points. So we're going to dig a little bit deeper and kind of try to help it all make sense in your brain if this is the first time learning about this topic. So let's kind of put into comparison. Let's pretend that this is a can that represents 55 degrees. All right, we have a larger can, it represents 75 degrees, and the biggest can represents 95 degrees. So warmer air can hold a lot more moisture. This is the warmest degree, right? 95 degrees. It's 95 degrees outside. That means our can is huge. That means the atmosphere is able to hold a lot more water versus if the temperature was 55 degrees outside. Okay? So now we're going to fill up each of these cans halfway. All right? Our 55 degree can is halfway full. That equals 50%. All right? So it's 50%, half of that, it's relative to the size. Our 75 degree can is filled up halfway at 50%. That's relative to its 75 degree temperature. Same story for the 95 degree can. It's filled up halfway, 50%, and that is relative to the size of the can. So relative humidity is a percentage of how much moisture is in the air versus how much it can hold. In other words, how full is our can? How full is our atmosphere of moisture? Each of these cans has a relative humidity of 50% right now. Now let's talk about the dew point. The dew point is the absolute measure of how much moisture is in the air. So what does that mean? How much water is actually in the can? Let's forget about the size of the can, but let's say that the dew point, 37 degrees of moisture, is in this can. All right? Although the relative humidity is still 50%. In this can, we obviously have more water, right? It's a bigger can, still halfway full, but that half of this can is still more water than this can would hold, right? If you would have put all of this water in this can, it would likely be full, if not filled even higher. But because of the fact that our can is larger, the temperature, we have half of that is actually more water compared to that. So it's 55 degrees, but the relative humidity is still 50%, right? Hopefully I haven't lost you guys here. Now let's take our biggest can, halfway full. This is a lot more water though. It's probably triple the size of the small can, right? The dew point is 75 degrees because this can is bigger. It can hold more moisture. Half of it though, it's still at 50% relative humidity. So do you understand how relative humidity can actually be a little bit more complicated and not the best way to describe to your friend or your mom or your dad or your grandpa how humid it is outside? Okay, so let's talk about what that means whenever the dew point is higher and how it feels. It's very important as meteorologists not only to explain how it feels outside for you guys, because depending on the dew point, it's probably going to help you get more motivated to get outside and get that outdoor workout in, or if you just want to stay indoors or open up the windows. Right now is the type of relative humidity where the atmosphere is dry, right? We're at about 45, I think our dew point was. So anything under 55 is considered dry. And that's when it feels nice and crisp outside. Okay, by this weekend, I want you guys to stay on top of the forecast with us and find out what the dew point is this weekend, because this weekend it's going to start to feel humid. So whenever we have dew points in the 60s, and I'm going to show you how you can log on online to track the dew point and kind of watch it together, you're going to notice it's going to feel a lot more muggy and the dew point number will be in the 60s. All right, whenever we have dew points in the 70s, it is miserable outside. It feels oppressive. It feels like the atmosphere is just weighing you down with so much moisture. And we do get there here in the Houston area because we are so close to the Gulf of Mexico, and it's a huge influence on our weather. Okay, this is the part where we get to be interactive. So I need you guys to tune in and comment below and help answer this question. So, all right. Which example feels more humid? This is a little quiz for you guys. And comment below. I'm going to give you a few seconds to do so. Is it can number A? Notice can number A, it's full. Its relative humidity percentage is 100%. The temperature outside, though, is 55 degrees. So let's take a look at can B. The temperature is 95 degrees. Relative humidity is at 50%. All right, so I'm going to give you about 20 seconds. Comment below which example feels more humid, and we'll see who gets it right. All right, gave you guys a few seconds. Okay, if you're tuning in, this was a little quiz, an overview of what we just learned. So we're trying to figure out which example outside would feel a lot more humid. We have can number 1, the temperature is 55. Relative humidity percentage is at 100% though, but this can, it's half full. Although it's a lot hotter outside, so we can hold more moisture, but the relative humidity is 50%. So the answer is B. Can number B feels a lot more humid. So atmosphere number B is holding, even though the relative humidity percentage is 50%, the dew point is still at 74 because this overall is a lot more moisture that we're feeling compared to this can. Okay? So if you guys got B, you win a golf clap. Okay, so hopefully that made sense to you guys. If the question is ever out there, how humid is it outside? make sure to let everyone know that don't look at the relative humidity, because that's not the best way to help understand how muggy it is outside. You want to look at the dew point. That is the most accurate way. Okay, let's take a look at radar, because there's factors that influence the dew point and the relative humidity percentage, but most importantly, the dew point. So yesterday we learned about pressure, right? If you tuned in yesterday, I spy an area of high pressure, which what happens with areas of high pressure, a recap from yesterday, it helps it become more sunny. It helps suppress rain chances. It brings in some drier air. Here's the reason why it's bringing in drier air. Here's this area of high pressure. I'm going to draw it in for you guys. If I can pull up my little thing, I can't pull it up. I don't know why my pencil is not popping up. Sorry about that, guys. But here's the area of high pressure. So I'm drawing in an area of high pressure. And the reason why I know that is because we have clockwise rotation around that area of high pressure. But this area of high pressure, it's wrapping around dry air, right? So we have a dry north wind. And that's why north winds help dry us out and bring in a lower dew point number, because we don't have any moisture really to push into Texas. Versus if we had a south wind, which those south winds will return this weekend, that south wind, where is it bringing in moisture from? What type of air mass is it filtering into Texas? The Gulf of Mexico. So that's why it's a lot muggier, and that's why our dew point numbers are higher whenever we have south winds, and usually we have dew points coming in around 60s, upper 60s, not feeling very comfortable. So dew points right now, almost everyone's in the 40s. Notice coastal areas, they're closest to the Gulf moisture. They have slightly higher dew points because dew points are in the 50s. Even though they are seeing a south wind, they still have the main influence from the Gulf of Mexico. Okay, and as we get, more into the summer season, we're going to talk about the feels like temperature, because the dew point is also something that calculates how it feels outside. So these numbers, because we have low humidity, it feels like the actual temperature outside, but it's whenever it starts to get hot and you factor in the dew point, there is a calculation that helps us figure out what it feels like outside, and that's when it could be dangerous. So that's why it is very important to know about the dew point. And if you want to dig even deeper and forecast the dew point and kind of know when it's going to be muggy or when it's going to be drier, I'm going to show you how to do that. So I'm going to pop up my favorite page that I do some forecasting with. I'm going to take you to Next Generation Weather Lab. So I've talked about this website before. If you're interested, you can Google Next Generation Weather Lab. And then if we click on here, I'll try to go to the main page in case you guys want to do this with me. I'll show you how to get there. All right, so this is the page that's going to pop up when you Google Next Generation Weather Lab. And then it shows us all of our computer models, right? We'll do the GFS model. You can pick any model and play around, because every model gives different information, and it's important to look at every single model as a meteorologist, because it's your job to put your best educated guess together with the information that each of these computer models show you. So you can't just go off of one. Okay, so we picked the GFS model. Now we're going to look at surface products, because the dew point is something that's at the surface. It's calculating how much moisture is at the surface where we physically are standing. And then we're going to go to dew point. All right, so this is the GFS model, and it is showing us what's going to happen for the next several days with the dew point. All right, calculating dew point right now at 45 degrees. That's what we have. We're in the 40s right now, so it's doing a pretty good job so far as to where we are. So let's fast forward and kind of see what's expected in the forecast. I'm actually going to go up. All right, but then we can't see the timestamp. So I'm actually going to go back down, because looking at the timestamp is important. It's right there. But how about I'll go up just for right now. Ooh, notice dew points are rising to the 50s. We're in the 60s, There you are. You see the blue shaded colors. It says 64 degrees now. That means it's starting to get muggy. Let's see when it's expected to start to get muggy. Friday. There you are. Now we can look at the reason why. If you want to play around, you can also look at the winds. So we can go to the temperature actually shows us the winds. It has a temperature and also our wind barbs. So let's see what happens on Friday. Why does it start to get muggy? Look at that. We have winds that have shifted instead of our, oh man, instead of our dry north wind that was bringing in a drier air mass, which is why humidity levels or dew points were in the 40s. Now our winds are shifting to a southeast wind, bringing in moisture from the Gulf of Mexico. Look at that on Friday. So kind of fun to put, you know, you have to look at all of the different products, different computer models, put them together, and you can put together your weather story. Okay. If you also want to look at the dew point forecast, National Weather Service, if you just want some quick data, you can Google National Weather Service Houston, and then they have the actual dew point right here. Here's the number, 45 degrees. So it also shows you the percentage, relative humidity percentage. But again, if you want to know how humid it actually is outside, 45 degrees, looking at the dew point, that's going to be your best friend. All right, so I'm going to let you guys go after we answer a few questions. Randy is on the phone with me, and he's going to let me know if there's any questions out there.
Yeah, there are, and you've answered a lot of them as we've gone. Preston wants to know if the higher dew point means more storms possible.
Ooh, good question. Sorry, my hair. I feel a loose hair. It was bugging me. Yes. So, what are some of the main components to create thunderstorms? We need moisture in the atmosphere, which is the dew point. That's showing how much moisture is in there, right? We need instability in the atmosphere, we need energy, we need the sun, and then we need a lifting mechanism, which is some type of frontal boundary, some type of system to help lift that moisture. So the higher the moisture content, which is the dew point, the higher the dew point, the better chance we have of picking up some storms. Good question.
Okay, and then I think you hit this one, but just to be sure, I think maybe Preston missed it. How do you calculate the dew point?
Good question. So I was totally going to put up some calculations, but it gets kind of complicated. It's a mathematical type of equation that gets complicated, and you'll learn that in college. I can totally pull it up on Google if you want, but it's even to calculate relative humidity, you're going to need to get into calculus for that.
Oh, okay. And I don't think there are any others that you haven't hit. I think
all right. Cool. Well, happy I was able to answer a lot of the questions. I'm happy you guys were able to tune in. You can rewatch this, and I, again, recommend you guys or invite you guys to look at the forecast with us and kind of track what's going on, the changes in the weather pattern. Remember, it's going to start to get humid by Friday. You can look at the winds starting to shift. You can look at the dew point number increasing, and you can also notice the relative humidity percentage number. The lower the temperature is in the mornings, that percentage is going to be higher, and as the day goes, you can kind of see that relative humidity percentage drop because we have a bigger can in the, that's able to hold more moisture in the atmosphere, so that percentage drops. So hopefully I made sense. I will let you guys go and get ready for the 411. So we'll see you later on KHOU. Have a good Tuesday.